when I was putting this slide deck together, I realized that not everyone here might know what the State of the Union is. It's a real Americanism. I suppose here in the UK I should do the State of the Empire or Commonwealth, something along those lines. The funny part about the State of the Union always is that the president basically gets on stage and he starts off and says, the State of the Union is strong, and then proceeds to prattle on for 2 hours describing all the ways in which it's strong. So I guess I could just stand up here and say, the State of the Kubernetes Union is strong, and sit down and be done. But I'm going to talk a little bit more about that. So there's a lot of ways to measure the state of the Kubernetes Union. But I think for better or worse, the best leading indicator we have is the activity that's going on the Kubernetes product. And right here you have a proxy for that. You have the number of commits since January of last year. And not only are the number of commits continuing to keep pace with the torrid pace we set when we first started this project, it's even accelerating beyond that. And it's not just raw commits flowing into the system. Every 3 to 4 months we get together, we do a full end-to-end test of the system and release it as a deployed binary that people can download and use on a regular basis. So it's not just raw tech. It's actually things that are out there that are production ready and people are using it in production. And you can see where we started this. In July of last year, we were at 1.0. In November of last year, just about 4 months later, we hit 1.1. And now we're talking about 1.2, which has just been cut to beta and will launch to GA by the end of the month. Some additional metrics specifically around our velocity, which is so important. I already mentioned commits, over 5,000 commits in that 4-month time frame between 1.1 and 1.2. We have 50% more unique contributors to the project over the course of that time. We're the top 0.01% of all GitHub projects, and over 1,200 external projects in GitHub are based on Kubernetes. So again, this isn't just us. This isn't just a small set of 10, 20 people in some company somewhere. These are real people out there in the community contributing, making this healthy, and making us a community that has real power. I have just a small subset of the companies who are already contributing to us, either through the CNCF or through raw code, and you can see a small subset of them here. And you can see companies using it. This, again, a small subset of real companies that are out there betting their businesses on Kubernetes, using Kubernetes in production, using it to vastly improve the way that they deploy and run software. So when I thought about what might be causing the fact that we're growing so fast, it basically broke down to 3 big things. First is the platform. It's tough to overstate the value of having a platform that is based on literally 10 years of knowledge, running containers in the most scalable, largest infrastructure in the world. Additionally to that, it's not something where it's a bunch of pieces that you piece it together. The key features, as you saw in Kelsey's demo, and I'll talk about some more today, are in the box. Things like service discovery, load balancing, health check, you name it. It's in the box. It takes care of those things for you. And again, you can certainly piece together those things yourself, but why would you when you can do it based on the wisdom of the crowd that's contributing here? And again, the platform has true portability. This is something we cannot stress enough. When you look at the combinations of OSs and clouds we support, it's as broad as anyone in the industry. You can take Kubernetes, you can run it on premises, you can run it on VMware, Vagrant, AWS, GCP, Rackspace, Azure, you name it, Mesos, everything. Kubernetes is a deployment fabric that works where you need it to work. And the best part is you're not locked in. You can take that Kubernetes installation, you can move it to a place that makes sense for your business rather than the ones that make sense for the core contributors. The second major area is the community. I can't stress enough how active the community is. I've been involved in open source for a long time. This is one of the most active communities I've ever seen, and it's not just active in the way that people contribute, but it's active in the way that people participate. People are in Slack, they're on GitHub 24 hours a day, answering people's questions, helping people get on board, using the platform. And finally, adoption. Nothing begets adoption like adoption. Everyone in this room has looked at or talked to someone who's using Kubernetes. They're out there, they're deploying it, they're using it, and they're telling all their other friends and all their colleagues how great it is to use it, and that's helping those guys get on board. And the reason people are adopting it is because you get to run containers like the largest container installation in the world. Who wouldn't want to run like Google? And not just that they're adopting it, but they're taking their wisdom, their learnings from going out and using it in production, and they're having that flow back into the system. Because Kubernetes is an open source project, it's been completely contributed to the CNCF. There's no benevolent dictators setting direction here. This is a community effort where people get together, they decide what makes sense, enterprises give their feedback into the project, individuals give their feedback into the project, and they make the product better. So our vision is what you see above here. We want to give everybody the power to run reliable, agile, distributed systems at scale. And with all that as the backdrop, the state of the union as it is today, let's look a little bit to the future, in particular to the end of March. So Kubernetes 1.2. We had two major things that we wanted to work on when it came to 1.2 as a summary. Number one, we wanted to help people get started quicker. And number two, we wanted to help people get big faster. And this is just a small subset of the things that we invested in around Kubernetes 1.2, you can see here. We have a brand new UI. I'll show you some screenshots there, but you're more than welcome to download and test it out today. We made significant improvements in scale, announcing a 400% increase in the number of nodes supported using roughly the same size masters that you use today. We made significant improvements to application deployment, so it's more declarative, and it works in the best practices way for rolling out applications and managing them. We did a number of different things around automated cluster management so that Kubernetes has visibility into the system that's running underneath it, as well as running in with awareness of different zones and common patterns that are used today when it comes to deployments. And this last point is one of the most important. We made significant investments in third-party extensibility. The idea here is that we don't want to be naive and think that we have every requirement that's out there in the world. With these third-party extensibility points, you're going to be able to take your own objects, create your own objects in a straightforward way, put them into the system, and get a first-class API to interact with them just like any other Kubernetes system. You don't like the DNS, get rid of it. You don't like the scheduler, it's yours. Do whatever you'd like. That's built in, and you can make those changes. And that really is just a very small subset of what's in there. We'll have everything in the release notes coming up and talk a lot more with our documentation and things like that. And it'll be available by the end of March. So with that, I'd like to just run through a couple of those scenarios that really are so compelling. You already saw a little bit of the demo from Kelsey today. I'm going to show you just a slightly additional amount of that, but I'd really encourage you to just go dive in. It runs and it's production ready as it stands. You can see here a new UI. Again, something that we've definitely heard is that there's a lot of surface area around Kubernetes, ton of power, not sure where to start. Sometimes you just want an image name, a port, a number of replicas, and to go. And that's exactly what you have here. The new UI will start by default. It runs in your cluster. It's not on some hosted service or anything like that. This is something you start up and can interact with on your own server. You click deploy an app. And it's not coming through terribly well on this screen, but you enter your name, a number of replicas, and a port. And you hit submit. You can even upload your own YAML file directly to the thing. And presto, it runs off and goes, and you can get great imagery around, how much usage and historical CPU utilization and all that good stuff. Again, really straightforward, lets you get going with containers in 3 clicks. Honestly, that's the entire experience. So that's the new UI. There's lots more there. I only have 25 minutes, so I'll breeze over it pretty quickly. But please do go download and take a look today. So then you talk about deployments. The problem with deployments as they stand today is there's a lot of manual interaction. You saw what Kelsey had showed earlier. Unfortunately, there's a lot of work involved in manually maintaining applications as they roll out. Today, you can do kube control rolling update, as Kelsey mentioned. It's a great tool, but it is client-side, and it's not declarative. You really have to understand what the state of your current system is, and potentially you have to create a second replication controller, fold that in. It's just unnecessary complex. The other option is SED, to Kelsey's point, the 90s called. It's not bad, but it's just a lot of work. So we introduced the deployment API, and I'll just walk you through this. As you saw up there, it's a single one-line command to using deployment. This is an example of a very simple deployment for Suite web app. I say 42 replicas, and then it's the exact same spec that you saw before. I'm correctly using a version number. I can't stress that enough. And I create a deployment. The deployment gets handed to the API server, and it goes out and deploys it for you. Great. Good times. Nothing special there. All right. Now I have a brand new version that I want to use to replace the previous one. I use the same deployment. I change my version number and create a brand new deployment. I hand that to the API server. The API server understands that this is a declaration by me, and then I'm going to go out and change it. Fantastic. Super useful. Oh no, I have deployed something and it is broken. What do I do? The beautiful part is, because this is a deployment, it's a standard API, you could just re-engage your previous deployment, push out the previous deployment as you had there. And not only that, it's actually stored on the API server, so you can do all kinds of things around auditing your deployments and things like that. Push it back out. Success. So that's the deployment API. Really powerful. It's a much cleaner way to interact and manage your applications. Number two, config maps. Again, Kelsey talked a little bit about this. Incredibly powerful. When you think about 12-factor applications, this is one of the most fundamental constructs. You want a binary that's the same no matter where you are. Whether or not it's dev or test or staging or production, you're using a single binary, and that binary flows all the way through. And then you should pick up your configuration based on the environment that you're running in. It's just best practices. You don't have to move secrets around. You don't have to run things, be worried that your binary was configured to run things in debug mode. It picks up the information and it configures itself appropriately for the space. And you can see a lot of the kind of bad practices to do today. Again, it works. It's just not ideal. So the solution is config maps. As Kelsey mentioned, they're late binding, they're live updating, and atomic. And they're available either as files that you saw as Kelsey mounted in, or you can mount them in as environment variables. In this particular case, I have an etcd config that uses a discovery URL. That's a super appropriate case for this. The discovery URL might change from different environments. I create my config map. I hand it to the API server, and it automatically pushes it down to the pods that are subscribing to it. So that's config map. Again, a much cleaner way to configure your running applications, either at initial deploy time or change configurations over time. And then finally, daemon sets. So again, incredibly common pattern. How do I deploy one and only one application to a node or group of nodes? You might have a log aggregator. You might have a security tool. You might have any number, an auditing tool. Any number of solutions where you do need to have some awareness of the underlying infrastructure that you're running on and deploy a node across them. Today, you can do things like over-replicate, where you just say, I'm going to want 1,000. You can grab a unique resource on that pod, making it on that node, making it one and only one deployment. You could run it outside of Kubernetes as potentially part of the startup script of the node. But again, this is something that we should push into Kubernetes because we do know how to manage it. So the solution here is daemon set. For example, if I want a sharder that shards a set of data across a set of nodes, incredibly straightforward. Apologies for the YAML, but you get the idea. Really straightforward. You just indicate an image and a port, and Kubernetes takes care of it for you. Okay? So those are just a few of the highlights that makes Kubernetes 1.2 even easier for both getting started quickly and getting big faster. As far as the future is concerned, Kubernetes 1.3 is weeks away, where weeks is on the order of 16. Here is a small subset. We've already talked about this at the community meeting, which I highly encourage all of you to attend on a weekly basis, except for this week, where we are in fact talking over the community meeting as we speak. This is a small subset of the things that we have already decided as a team that we are going to allocate engineers to. This is a small subset, but these are some of the things that we've heard most from customers. The first is around legacy application support. You might have previously heard this around PetSet, still determining the name. Basically, there's a whole bunch of things when it comes to legacy applications around persistent IP addresses, around identity as part of a set, around mounting in stores that we want to support as part of Kubernetes 1.3. We're going to have work against cluster federation, aka Kubernetes, where multiple clusters will be able to see each other, develop a trusted relationship, and be able to spread workloads across those various things. We will continue to invest in scale, and we're very optimistic we're going to have similar or better improvements as we made in 1.2. In-cluster IAM for linking in with common IAM solutions such as Active Directory, LDAP. Cluster auto-scaling, where Kubernetes will be able to surface metrics to your underlying infrastructure to grab additional compute when a pod might be pending due to lack of CPU. Scheduled job, Kelsey mentioned that earlier, where you have something that potentially is running like a cron. You'll be able to schedule that into Kubernetes. And then finally, a public cloud dashboard where you'll be able to log in and see regular test results from major cloud providers so that you can be sure that that Kubernetes is supporting the place that you want to deploy. Again, with our vision of total deployment, total portability. And lots more. And again, we are open for proposals now. This is something where we want to work with you. Kubernetes has been very, very open and transparent that we want to make other businesses successful. We've donated the entire Kubernetes code base to the CNCF. There's no business model behind Kubernetes. We're not going to go out and try and steal your business. This is a place where we want you guys and all the folks live streaming at home and downstairs and you name it, making all the money. Kubernetes is a platform that is owned by you and that will enable you to build big businesses on top of. And speaking of the CNCF, please allow me to bring Alexis up to talk. Alexis is the chairman of the TOC for the CNCF.
Can you hear me on the mic? Yep. Good. Can you hear me now? Great. Okay, so Dave has already announced that Kubernetes is part of the Cloud Native Computing Foundation. This is an amazing thing, and I want to talk to you about it for a few minutes, hopefully not too long. My name is Alexis Richardson. I'm the founder and CEO of Weaveworks, or co-founder. Catch me at the party tonight if you want to talk about this. I'll be here all day as well. So, what is Cloud Native? It's going to be a much bigger thing. It really is going to be a huge thing. It's not just Kubernetes and Docker and Mesosphere. There's going to be a lot of projects that are cloud native, and all of these projects share one goal, which is to make your IT go faster and run anywhere through automation and through integration, as Kelsey and Dave have shown this morning with Kubernetes. And the Cloud Native Foundation exists to be an Apache of cloud native, to be an open foundation to allow anybody to collaborate to drive this mission forward. Whether it's for microservices or containers or orchestration, all of these things fit under the umbrella of cloud native. So what's the story? Why did it happen? One of the key projects in the space is, of course, Kubernetes. That's why many of you are here today. Several years ago, Google did an unusual thing, which is they decided to take some code, and rewrite it and make it open source and see if other people would use it. Now, the agenda here was to get people writing code in a new way so they could move it around different clouds. This would, of course, support Google's cloud business and efforts in the hybrid cloud. So that was the business reason for doing it. But for technical people, this is a new way of writing applications. They can run anywhere. They can scale easily. So people started to use it. And then more people started to use it. And more people started to use it. Now, if you go on Slack, there's well over 3,000 people there regularly talking about Kubernetes. And as Dave said, that is an impressive thing, the way they interact with each other. And so now you suddenly have real companies, big companies, saying, how do we get involved? And you have people sticking up their hands in small companies or small independent teams and saying, how do we get involved? And it turns out that today, not everybody wants to write a CLA and contribute code to Google and then expect Google to be the long-term enterprise support vendor for Kubernetes. And so that was the seed of a change where people said, let's take Kubernetes and we'll move it into a foundation. And then everybody can collaborate the same way they do around Apache Hadoop or Tomcat or some of the other open source projects, some of which are very famous. I'm not going to run through the whole list. And so that's what's changing here. So then there were some conversations. Where should it live? Should it be on Apache? Should it be somewhere else? And it turns out that, for various reasons, not everybody felt that Apache was the right home for this technology. And if you look at how developers write code today, we live in an era of GitHub, completely free-form collaboration. So with the CNCF, we're going to create a new set of structures that reflect that reality and align well with how developers want to work today. That's what I mean by an Apache of Cloud Native. Very similar in spirit, but run with a slightly different set of rules, and the projects will very much be driven by their own way of working. It's part of the Linux Foundation. This is the parent organization. It's trusted. It's been here the longest. Everybody knows where it stands. If you are running an open source project that you think is cloud native, come and talk to us. Maybe it should be part of the Cloud Native Foundation. The CNCF and the Linux Foundation are there to help you. We are your servants to make you successful with your open source projects. So the CNCF was formed last year. All of the main players in Cloud Native are involved. Docker, Mesosphere, Khoros, Google, ourselves at Weaveworks, Cluster HQ. You know the list of names. And now, finally, after lots of work, we can announce, and I'm really pleased to say this is true, that as of today, Kubernetes is part of the Cloud Native Computing Foundation, so that now everybody can get involved in a whole new way in helping Kubernetes move forward. So I think that really deserves a round of applause. So I kind of Kubernetes. I mentioned there are other cloud-native projects out there. Maybe they're using Docker. Maybe they're using Mesos. Maybe they're using both of them. Maybe they're using that with Kubernetes somehow. Maybe they're doing something else. Maybe it's a time series database. Maybe it's another implementation of Raft. Maybe it's a tracing product. Come and talk to us. We want to be your home for these pieces of technology and help you be successful. Thank you very much.
As you all know from my copious announcements earlier, we started a bit late, so we're actually going to super compress this break and try and get us back on schedule. So we are trying to start the next breakout session at 10:55, which is roughly 6 minutes from now.